Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today we're going to be talking about some more problem-solving strategies, and we're going to be, in particular, talking about geometry and uniform motion word problems. Now, I know when you look at the book, you see all these words and numbers, and you get a little timid, you get a little afraid. Please do not be afraid. I'm going to walk you through this step by step. However, everything that we've learned so far is very important to remember, okay? Especially the direct translation. If you still have not mastered 2.5, I believe that this will be a little bit of a challenge for you. But I believe in you, and I know that you can do it. So let's get right to it. First of all, let's talk about uniform motion word problems. When we're talking about uniform motion, they're going to be asking for either the distance, the rate, or the time. One of the three. And in order to be able to solve these kind of equations, one must know the formulas. And the formula for distance is D equals RT, where D is distance, whether it be in feet or miles or yards or meters or centimeters. The rate is speed, whether it be in miles per hour, feet per second, or meters per hour, kilometers per hour. And T is time, whether that be in hours or minutes or days or weeks. So D, distance, equals R, which is rate, times T, which is time. Now there are three types of uniform motion problems. The first type of uniform motion problem is when one, let's just say, event is going one way, and then you have another event going towards that first event, or let's call it trains. You have train A going one way, you have train B going towards the train, and they're going to meet here in the middle. That's one type of uniform motion problem. Second type is when you have a train leaving from the same station, for example, and one train goes in one direction and the other train from the same station goes in the other direction. And the third type of uniform motion that you have is when you have one train that leaves earlier than a second train. And then the second train, since it left later, has to increase its speed, and it's trying to catch up with the first train. Now, all three of these can be very easily solved if you use the following table. If you make this table every single time, I promise you, life will be a lot easier for you when it comes to these kind of problems. You're going to make a little table, as you see here, where you have the event. It's going to be an event A and B, or person 1 and 2, for example. You're going to have the rate. You're going to have the rate of A, and then the rate of B. You're going to have the time of A, the time of B, and then you're going to have the distance, which is the product of R and T. So this would be the rate of A times the time of A. That's my distance. And then the distance for event B is the rate of B times the time of B, and that would be my distance for event B. So please follow the table. If you use the table, I promise you, this is going to be very simple. Let's show you how it works, gentlemen. Okay, number one. Frank and Mike drove from Atlanta, Georgia to Durham, North Carolina, which are 390 miles apart. Their average speed for the first part of the trip, that's a key word right there, was 60 miles per hour. Due to road work, their average speed for the remainder, so the remainder would be the second part of the trip, okay? The remainder of the trip was 45 miles per hour. How long did they travel at 45 miles per hour if they drove 3 hours longer at 60 miles per hour than 45 miles per hour. Okay, before you give up, just pay attention to the table. It's all about the table here, my friends. Remember, you have your event, and this is rate times time equals distance. And the event, okay, you have the first part of the trip is one event, and then the second part of the trip is one event. The first part of the trip very clearly states that you were traveling at a rate of 60 miles per hour. So rate is 60. For the remainder of the trip, or your second part of the trip, you were traveling at 45 miles per hour. So you already have some of the table filled in. They ask you how long, so we're looking for time here. How long did they travel at 45 miles per hour if they drove 3 hours longer at 60 miles per hour than 45 miles per hour? Remember from direct translation that when you have a comparison like this, 9 out of 10 times, the second part of the sentence is going to be your X. So you know that they drove 3 hours longer at 60 miles per hour than at 45 miles per hour. So what do we know nothing about? Hopefully you realize that you know nothing about the time that they drove 45 miles per hour. But what do you know about the time of driving 60 miles per hour? It was 3 hours longer at 60 miles per hour than at 45 miles per hour. So let's think about what happened here, guys. You have the first part of the trip, you went a certain distance, right? Plus then, the second part of the trip, you went the remainder of the distance. So in total, the whole entire distance was 390 miles. But that was made up of the first part's distance plus the second part's distance. So the first part's distance, remember that distance equals rate times time. So please distribute. So the distance of the first part is 60x plus 180. The distance of the second part of the trip is 45 times x, which is 45x. So now, think about what we just drew here. You have the first part of the trip plus the second part of the trip equals 390 miles. And now once you've set up the equation, solving is the easy part. 60 plus 45 is 105x plus 180 equals 390. Subtract 180 to both sides. 105x equals 210 divided by 105. X equals, hopefully you got, 2. And since we're talking about time, that's 2 hours. Now, we're not done. The question was, how long did they travel at 45 miles per hour? Well, at 45 miles per hour, that's equal to x. So they traveled for 2 hours at 45 miles per hour. If they asked for how long did you travel at 60 miles per hour, you would plug the x into the time of 60 miles per hour, which would be 5 hours. And bada bing, bada boom, you're done. Let's check out another one now. Number 2. 2 groups of friends took a canoe trip down the New River. The first group left Canoe Outpost at 12 noon. 1/2 hour later, the second group left Canoe Outpost, paddling at an average speed that was 0.75 miles per hour faster than the first group. At 2:30 p.m., the second group caught up to the first group. How fast was each group paddling? Sorry, there should be a was here. I apologize. How fast was each group paddling? Okay, so let's do it. Let's make our table. Actually, let me make it a little bit wider. Okay, my event is group 1 and group 2. Rate times time equals distance. Okay, the first thing, let's look at the rates. Says here that the second group left 1/2 hour later, paddling an average speed that was 0.75 miles per hour faster than the first group. So what do we know nothing about? Usually it's the second part of the sentence. The first group, we know nothing about their rate. So that's X. And what do we know about the second group? That it's the 70.75 miles per hour faster than group 1. So it's X plus 0.75. The time. Group 1 left at 12 noon. Okay? Group 2 left a half hour later. And they caught up at 2:30. So group 1 was traveling for 2.5 hours. Group 2, since they left a half hour later, only traveled for 2 hours. So what is my distance? My distance of the first group was 2.5x, because rate times time equals distance. My distance of the second group, distribute, is 2x times 1.5. Plus 1.5. Because it's 2 times x plus 2 times 0.75. So now, what's happening here? Well, group 1 left. Then group 2 left a little bit later, and they caught up to group 1 at 2:30. So if they caught up to them, doesn't that mean that their distances have to be equal? Hopefully by this diagram, you see that the answer is yes. Their distances are equal. So the distance of group 1 equals the distance of group 2. Now you solve. Subtract 2 to both sides. You've got 0.5x equals 1.5 divided by 0.5. X equals 3, and this is a rate, miles per hour. How do you know it's a rate? Because that's what we were looking for, a rate. So group 1 had a rate of 3 miles per hour. Group 2 had a rate of 3 miles per hour plus 0.75, so that would be 3.75 miles per hour. And bam, you got it. All set. The table is the key here, gentlemen. The table is the key. Let's do another one. Number 3. Jasmine runs at an average speed of 8 miles per hour. 2 hours after Jasmine leaves your house, you leave in your car and follow the same route. If your average speed is 40 miles per hour, how long will it be before you catch up to Jasmine? How far will each of you be from your house? Well, let's make a table. Always make a table, my friends. You've got the event, and then you have rate times time equals distance. So the event here is Jasmine running, and then you in your car. It says here very clearly that Jasmine is running at an average speed of 8 miles per hour. 2 hours after Jasmine leaves your house, you leave in your car and follow the same route. If your average speed is 40 miles per hour, okay, so now we have the rates. Now, time. It says here that 2 hours after Jasmine leaves your house, you leave in your car. So, what do we know nothing about here? We know nothing about Jasmine's time. We have no idea how long she was running for. So that's X. However, we do know that 2 hours after Jasmine left your house, you followed her in the car. So that means that you are traveling for X minus 2 because she was already traveling for 2 hours. You left 2 hours later. Now, if you wanted to, you could also make yourself X and Jasmine X plus 2 because she was riding for 2 hours, she was running for 2 hours more than you. That one is interchangeable. But I'm going to stick to my original one. Okay? So what is Jasmine's distance? Well, Jasmine's distance is rate times time, which is 8x. What is your distance? Well, your distance is rate times time. Please remember to distribute. So that's 40x minus 80. Now let's think about what's happening. Jasmine left and went a certain distance. Then you left 2 hours later and caught up to her. So in the end, both of you are the same distance away from your house. So both distances are equal in this case. So I have 8x equals 40x minus 80. Subtract 40x to both sides. And I've got negative 32x equals negative 80. Divide both sides by negative 32. And x will equal here. Oh, sorry about that. X will equal here. You can divide both by 8. Actually, you can divide both by 16. So you have 5 halves, which is 2.5. And again, we're looking for time. So those are 2.5 hours. So how long was Jasmine running for? She's X, that's 2.5 hours. How long were you driving for? Well, you're X minus 2, so that's 0.5 hours. And that's what we were looking for. How the time, okay, how long will it be before you catch up to Jasmine? It's going to be half hour before you catch up. The second part of this asks, please read carefully, how far will each of you be from your home? Well, we already know what X is, right? So Jasmine's distance, remember that's 8x, so that's going to be 8 times 2.5, which is 20 miles. And you are going to be 40x minus 80. So that's 100 minus 80, which is also 20 miles. Because in this figure, it shows that your distances will be equal. And that's all it takes for distance problems, my friends. Take your time and make your tables. Next, geometry word problems. I know that some of you don't know the basic perimeter and area formulas. So what I did here was I got you a little website here that shows you the perimeter formulas, as you can see right here. Please hit pause on the video right now and write these down and commit them to memory. This is the perimeter for a square, a rectangle, a triangle, A right triangle, this one don't worry about too much. We're not going to use that until a while. Still write it down. And then definitely a circle is called circumference. Okay? So again, pause it, write these down, and memorize them. Now that you're done with your perimeter formulas, let's go to my area formulas. And my area formulas are all right here as well. Please hit pause, write these down, and memorize them. Okay? Memorize them. Don't worry about this guy either. This is a little bit more advanced. We'll get to that later on in the year. But do memorize the square, rectangle, triangle, parallelogram, trapezoid, and circle areas. So again, please hit pause, write these down, and memorize them. Okay. Now, let's talk about something that wasn't there. Let's talk about complementary and supplementary angles. Complementary angles are angles whose sum is 90 degrees. When working with these types of word problems, you got to remember the following fact. When they're just talking about an angle and its complement, the angle is unknown, so we call that x. But the complement is 90 minus x. Why? Well, if the angle and its complement equal 90, and you don't know what the angle is, logic states that the complement will be 90 minus x. Think about it like this. If one angle is 30 degrees, its complement would have to be 60 degrees because 30 plus 60 is 90. How did I get the 60? 90 minus the angle 30 gives you 60. So when I have an angle that's x, when they say complement, that's 90 minus x. Very similar pattern occurs with supplementary angles. Supplementary angles are angles whose sum is 180. When working with these types of word problems, remember that the angle is x again, but this time the supplement is 180 minus x. Again, if I have two supplementary angles and angle 1 is 100 degrees, the supplement of that will equal 80. Why? Because 180 minus angle 1 equals 80. So the angle is just x. The supplement is 180 minus x. Now let's put this to play. All right. Find the measure of two complementary angles such that the measure of the larger angle is 6 degrees greater than twice the measure of the smaller angle. They're not using the word complement here, so you do not have to use 90 minus x. Rather, you make a table for the larger and the smaller angle. It says here that the larger angle is 6 degrees greater than twice the measure of the smaller angle. So the smaller angle in this case is your x. That's the unknown. It's 99% of the time, the second part of the sentence is the x. What do we know about the large angle? That it is 6 greater than twice the measure of the smaller angle. So it is 2x plus 6. Now, they're complementary angles. So that means that the sum of both angles is 90. So that means that the large angle plus the small angle equals 90 degrees. Now just solve. 2x plus x is 3x, plus 6 equals 90. Subtract 6 to both sides. 3x equals 84 divided by 3. X will equal 28 degrees. I want to find both complementary angles. So the small angle is 28. And then 2 times 28 plus 6 gives you 62 degrees. Very simple if you make a little comparison chart or a comparison table. Okay, number 5. An angle is 30 degrees less than twice its complement. Remember what we said here. The angle will always be x. The complement will always be 90 minus x. If they had said supplement, then it's 180 minus x. So now let's just read. An angle, x, is equals 30 less, not less than 30 less than, remember that means switch. So it's 30 less than, so put 30 back here, twice its complement. 2 times the complement of 90 minus x. So again, an angle is 30 less than twice its complement. Now it's easy. X equals, remember to distribute the 2, please. So x equals 180 minus 2x minus 30. Add 2x to both sides. So I've got 3x equals 150. Divide by 3 to both sides. X equals 50 degrees. I want to find both the angle and the supplement. So the angle is x, 50 degrees. The complement is 90 minus 50, which is 40 degrees. And since 50 plus 40 equals 90, you're golden. All right, let's change gears now. Before I do anything here, let me explain to you guys that the sum of all of the angles, so that means the sum of angle A plus B plus C, the sum of all of the angles of a triangle will always equal 180 degrees. The sum of the angles of any triangle will always equal 180 degrees. The sum of the angles of any triangle will always equal 180 degrees. That being said, let's read the word problem. The measure of the largest angle of a triangle is 20 degrees more than twice the measure of the smallest angle. And the measure of the second angle is 10 degrees more than twice the measure of the smallest angle. Find the measure of each angle of the triangle. All right, so I have a large, a small, and the second. I guess I could have made that of the medium angle. Make our lives easier. So we've got the large angle, the medium angle, and the small angle. This is all direct translation from here. Says, the largest angle of the triangle is 20 more than twice the measure of the smallest angle. Smallest angle is at the end of that statement, so that's what we know nothing about, so we're going to call that x. And the largest angle is 20 more than twice the measure of the smallest angle. So this is 2x plus 20. The medium or second angle is 10 degrees more than twice the measure of the smallest angle. The measure of the medium angle is 10 degrees more than twice the measure of the smallest angle. So 2x plus 10. And now it's Mickey Mouse at this point. Why is it Mickey Mouse? Because the large angle plus the medium angle plus the small angle must equal 180 degrees. Now just solve. 2x plus 2x plus x is 5x. 20 plus 10 is 30. And that equals 180. Subtract 30 to both sides. 5x equals 150. Divided by 5 to both sides. X equals 30 degrees. So my small angle is x, which is 30 degrees. My medium angle is 2 times x plus 10, which is 70 degrees. And my large angle is 2 times x, which is 60, plus 20, which is 80 degrees. And in total, 30 plus 70 plus 80 is 180 degrees. And you're golden. Okay, 2 more, guys. Number 7. The perimeter of a rectangular swimming pool shown is 80 feet. If the length is 10 more than twice the width, find the length and width of the pool. Hopefully you wrote down already the formula for the perimeter of a rectangle. The perimeter of a rectangle is 2 times length plus 2 times width. Well, we're going to have to figure out what the length and the width are. It says here that the length is 10 more than the width. So what do we know nothing about? We know nothing about the width, which is x. And it says the length is 10 more than the width, so the length is x plus 10. I want to find the length and the width. Now simply plug these in to the formula. You know that perimeter equals 2 times length plus 2 times width. So now we're just going to evaluate. They tell you the perimeter is 80, which equals 2 times length, which is x plus 10, plus 2 times width, which is x. Now solve. 80 equals, please distribute. This is 2x plus 20 plus 2x. This gives you 80 equals 4x plus 20. Subtract 20 to both sides. 60 equals 4x. Divide both sides by 4. And x equals 15 feet. So my width is 15 feet. And my length is 15 plus 10, which is 25 feet. And that's my answer. And last but not least, my brothers, a garden in the shape of a trapezoid, okay, between a sidewalk and curb has an area of 18 square feet. The height is the height is 3 feet. Sorry about that. The height is 3 feet. And the length of the shorter base is 2 feet less than the length of the longer base. Find the length of each base of the trapezoid. Well, first things first. This is a trapezoid, my friends. Hopefully, like I asked you to do earlier, you memorize the formula for the area of a trapezoid. And the area of a trapezoid equals base 1 plus base 2 times height divided by 2. They gave us the height already. They gave us the area already. So what we need to find is base 1 and base 2. So let's make a little table. They tell you very clearly that the length of the shorter base is 2 feet less than the length of the longer base. So what do we know nothing about? We know nothing about the longer base. So we call the longer base x. And the shorter base is 2 feet less than the length of the longer base. So less than, you switch. That'd be x minus 2. Now just plug in and solve, my brothers. Area equals base 1 plus base 2 times height divided by 2. The area they already gave you is 18 equals base 1, which is x minus 2, plus base 2, which is x, times height, which is 3, divided by 2. So we can simplify this so that it's 18 equals 2x minus 2 in parentheses times 3 divided by 2. Now let's solve. How do I get rid of this 2 in the denominator? I multiply everything by 2. 2 times 18 is 36. These 2's cancel. Distribute the 3, please. That's 6x minus 6. Add 6 to both sides. 42 equals 6x divided by 6 to both sides. X equals 7. So now go back to your table. Since x equals 7, that means base 2 is 7. Base 1 is 5. Feet, of course. Gotta label the units. Bada bing, bada boom. We're done. I hope that makes sense. Take your time. Follow the tables. I believe in all of you. Thank you so much. I hope you learned a lot and have a great day.